Well, I chickened out, everybody, and went and found the circuit diagram, and I'll probably try and put a link to this on the video somewhere, because it's always useful if I do that, because then you guys can help me when I get stuck. So we were looking at these transformers, these three transformers, and it looks like the two of the transformers that I were looking at were to do with the actual output side of things. It looks like the AL84 is the output valve, and in the same way that you would have a transformer coupled loudspeaker, you can actually connect the anode to various tappings on this transformer 1 and transformer 2, and I can only guess that that's being done to match the impedance into either the 5 ohm or the 600 ohm output. But what I can't understand is, why didn't they use a single multi-tap transformer? Is it that they were just being cheapskates and using transformers that they had from another piece of equipment? Or is there some reason for doing that? Yeah, that's all they must be doing. That just must be, it's just a tapped output transformer. And it will be done to impedance match this EL84 with the big changes between either a 600 ohm load or a 5 ohm load. But why didn't they use one transformer? I don't know. If somebody knows the actual answer to that, leave it in a comment. Thanks. Right, so I'm going to replace these capacitors here, and I'm going to cut these out, and I've just put a mark on the circuit board here because these capacitors have got a line down them, and I can't say that I'm certain, but I'm suspecting that the reason for that this band around the capacitor, I think it's showing you that the case is connected to the negative side, so it probably doesn't make a huge amount of difference, but we'll try and put it back how it was. Now, I don't know what the makeup of this type of capacitor. This is just a sort of capacitor I usually replace them with, and I don't know if this has got any form of shielding on it or not. I think I'm just going to stick it in. It has got a line on it, but whether that line actually denotes anything, I've got no idea. I guess for the sake of it, I might as well put it in that way around. Again, I know you guys, if you know better than me, you'll leave it in the comments. If I've done it wrong, I'll change it. But I've put a mark on the chassis in green pen here, just to show which side these lines were previously lined up at. I've got to disconnect this old capacitor, and what you might quite often do is just put the soldering iron on and pull the wire out. But I don't generally like doing that, because what tends to happen is you just heat up the tag strip and everything else, and you end up damaging things. So I usually find I prefer to cut out old capacitors and just put new ones, just solder the new ones in. So let's just see if I was correct about the this band here being connected to this side of the capacitor. These feel horrible and sticky. I hate this fluke meter sometimes. It's always bloody well switching itself off constantly. Oh no, that was a fail, so it wasn't connected to it anyway. So disregard everything I said there. I was obviously talking bollocks. No, so this can isn't connected to either side. I was sure that line there was going to say that, just to show you that this can was connected to this negative side, but it isn't. If I decide to keep this, I'll probably go ahead and change all the capacitors out on this, but to be honest, I'm probably not going to use this, so they probably won't bother spending the money on it. Going to run some more. What I'm going to do is I'm just going to tack the new capacitors in temporarily. I'm just running some new soldering, because all joints, the solder gets really hard, and I believe the reason for that, the way I understand it, is because the actual copper is actually slightly soluble in tin, and the copper migrates into the tin and raises the temperature. So if you've got solder joints on old equipment, they're often very hard to desolder. So like I say, we're just tacking these in temporarily. If if it all works, we'll come back and we'll make a proper job. The other thing I like to do is, because again I've got a memory like a sieve, I tend to leave the cut the capacitors off a little bit shorter and leave the wires in, and that just gives me a guide to where to put the new ones into. I'm sorry, the only thing you can probably see is my hands, but it's one of them things that it doesn't seem to matter where you put the camera. Your hands are always in the way. But you're all thinking, God, he's rubbish at soldering, but I actually think I'm generally pretty okay at soldering, but I'm trying to reach over things and I'm shaking, and because I've not, been able to allow me to film this and you guys to see it. It's nothing set up in a very easy position. So right, we've got them new interstage coupling capacitors in now. I would expect these valves are going to be fine, because I can't see that a signal generator is a piece of equipment, especially if it's come out of a school, is going to have had a lot of use. And looking at the valves, these look like brand new. There's no sign of the usual heating or staining on them. They look like new, so I suspect this piece of equipment probably hasn't had a lot of use. I'm just giving the valve sockets a bit of a clean, because you can spend a lot of time wasted tracking things down which like just a loose valve socket. So I just like to give things a bit of a clean first, and then you don't waste that time chasing red herrings. I'll probably take this can off later. I'm suspecting that all the tuning component goodness, the variable capacitor will be under here, which will be the main tuning control, and there's probably also some capacitors there associated with the range settings, but I suspect they won't be electrolytic capacitors, and therefore they stand a chance of being in reasonable order. Well, I was just going to plug this in, but I've taken a little bit of sympathy on it, and I will run it up a little bit gradually. I'm actually just going to turn it up on the variac to give these capacitors a little bit of a chance to reform. But I've seen a lot of people doing this, just running them up on variacs, and it doesn't really work as a technique. The idea is you turn the power up and these capacitors are going to reform a little bit. One, I don't really believe that capacitors do reform particularly effectively. If they're on the way out, they're on the way out, they need replacing. But two, the actual EZ80 rectifier valve won't actually start conducting until the voltage is pretty high anyway. So these capacitors are going to get hit by pretty much the full HT anyway. So if you're going to reform the capacitors, what I would normally do is take the rectifier valve out and just drop in just a normal silicon rectifier diode, and I would run the power up gradually that way. But I'm not doing that, I don't care that much. So let's just turn the power on and see if anything happens. I want to call them smoothing condensers today. I much prefer the word condenser to capacitor. Maybe I'm going to start saying condenser just because I know that'll annoy everybody. So I've clipped on the output lead to the smoothing condenser. It's going to really annoy the American viewers, that, isn't it? That's an even better reason to do it. So I've got the output of the voltmeter clipped onto the smoothing condenser, and we will run up the variac, turn the voltage up. We'll turn it up slowly, and we will see if we get any DC. We've got the lamp limiter in circuit, so if anything really nasty happens, we'll know. And I can also see the current that we're drawing here on the on this I don't know, wall wart energy monitor, power plugging, what is it, plugging power monitor, yeah, it tells you the current, whatever. Right, okay, so let's run the power up. So we've got 100 volts on there and nothing's happening. Wouldn't expect it to. Drawing 200 milliamps at the moment, nothing to worry about. Got 150 volts going into it now. Still not getting anything, any DC output. Again, wouldn't expect it to. Hopefully just before 200 volts it should start to come up. Okay, actually a bit short, 170 volts, and the DC voltage is now starting to come up on those capacitors, and we'll probably leave it at that for a little while just to give those capacitors a chance to reform. As I say, I think this whole idea of reforming capacitors, I understand the physics behind it, but I think it's bullshit. The reason that your capacitors need reforming is because they're old and they're knackered and all the dielectrics dried out. So actually trying to reform them, I don't think it works, and generally the best thing to do is replace them. HT's coming up, we're at 90 volts now. 100 volts, 102, 104, it's climbing quite rapidly now. And I think that'll be okay. But I'm going to go and leave it there. We've got the mains AC voltage set just to about 160 volts now. And our bulb is glowing dimly there. Very dimly, so that's fine. I think what we'll do is we'll go and have a cup of tea, and we will leave just to settle for half an hour or so. Well, it's a little while later, and I've been running this up on the variac, and we've got an output DC voltage from the rectifier of about 320 volts. And then on the second smoothing capacitor we've got 300 volts, because it's got one of those resistor capacitor low pass filters, just to increase the smoothing, and it seems to be working relatively well, in terms of the power supply's okay anyway. So I've been keeping an eye on the output, so on the smoothing capacitors and all the other electrolytics, and you know, turning it off every now and again and touching things, and everything's running cold or cool as it should be anyway. So I think now it's actually time to do some output tests to see if it's actually working, and I suspect it will be, because my experience of valve equipment is that, well, it takes a lot to stop it working. These things are usually pretty tolerant to changes in tolerances of components and stuff like that. It's amazing how some of these old boat anchors can limp around. And I was also looking at the specification sheet for this, and I've noticed that I think the specification, depending on what output level you're on, it gives it between 1 and 2% distortion. So really, by modern standards, this signal generator isn't really going to be particularly good for anything. For some reason I had in my head the fact it would be you know, a low distortion unit, and probably at the time of its manufacture 1 or 2% was pretty low distortion, but it's certainly not going to be useful for testing amplifiers today. Anyway, but it's been a good little project. It's been pouring down all day today, Saturday, so it's kept me in the dry. Right, okay, let's turn it over and let's plug a scope in and see if it's doing anything. Well, as everybody knows, there's actually only one way to test a low frequency oscillator, and that's basically to plug a speaker in and see if it'll do the old wobbly knob test. So here we go, we've got the speaker plugged in. So let's just turn up the output attenuator here, and let's do the big wobbly knob test. So the frequency goes down from a kilocycle and goes up to 4,000 cycles on that range. Let's do the top frequency, which is 4 kilocycles to 50. So we're on 50 at the moment, so I can't hear that. Sorry to all the dogs out here. Okay, I can just about hear that. That's 10. That's 4. So that works. Let's do the 15 kilocycles to 300 cycles. And of course now I can't hear that. Frequency is far too low. And there we go. .300 cycles. So yeah, it's doing something, but it did slightly sound like it had that square wave quality to me. It could just be that this speaker's crap, which it is, but it sounded as though it just had that, you know, that little bit of a harmonic quality to it, like a bit of distortion. So I guess what we've got to do is got to plug a scope in and find out, haven't we? It looks like, interestingly enough, it looks like the off button here doesn't actually turn everything off, because it's left the power light on, so I'm guessing the transformer stays on and this just actually switches the output on and off. And I think I can see the yeah, it does. So that power switch just appears to actually switch off the output the output from the signal generator, because I can just see the top of, from where I'm sat here, I can just see the top of the EZ, whatever it is, EZ80, whatever it is. I can just see the output of the top of the rectifier valve just glowing slightly. So that's interesting. It doesn't actually turn the mains power off. I'll just have to check the circuit diagram for that. Anyway, let's get a scope out. Well, I've been following Simon's adventures where he's been repairing his oscilloscope. I don't know if it was a 2440 or something he was repairing, and I thought that the scope that I had was the same. I've just pulled this out of a back cupboard. I haven't used it in years because it developed a fault, and I'd already replaced the scope, and I didn't bother investigating it because, to be honest, I thought it was probably beyond me anyway. What the fault is, when it's been on a while, it actually just locks up, and I don't know the reason why. At first I just thought that it was not triggering, but I actually think that there's something on here that's actually locking up, because none of the controls work. But as soon as you switch it on and off, switch the scope on and off again, everything starts working again as normal. So I could probably do with investigating it, or yeah, might even just see if it wants to go and live with Simon for a bit, because yeah, I'm scared to even take the top off it. I know it's going to be horrible. I expect it'll work perfectly now though, you know, it's kind of that sod's law thing, isn't it? Well, I'm just re-recording some of the footage because I noticed, again, my wireless microphone that I use, my lapel mic, had gone flat, and I'm not sure how much is recorded and how much hasn't, but yeah, the signal generator does appear to work. We've just got it set to the 4 to 50 kilocycles range at the moment, and it's showing there that we've got an output of 49.65 kilohertz. Let's just have a look at the 4 kilocycle output. It's funny how spoilt we are with these modern computerized scopes, in that I've just been playing with this, pushing buttons, and, you know, trying to remember how to work the thing, because you know, it's been a while since I've actually played with one of these. The other strange thing about it, I suppose it isn't strange, but whenever you want to do a measurement, it actually takes a measurement, but it isn't actually live. So it's saying that the frequency on channel 1 is 3.9 kilocycles. Can I make that a bit brighter? Focus isn't fantastic on this. You seem to get the trace in focus, but annoyingly that puts the text slightly out of focus, and then you focus the text and the trace is out of focus. Annoying. Well, I even forgot where I was going with this. Obviously, just waffling. Oh yeah, what I was trying to say is that this has taken a measurement, but if I actually alter the frequency, you can see that the frequency measurement doesn't actually update. What you've actually got to do is make it measure again. And yeah, well, to be honest, I'd forgotten about that. And you seem to be constantly adjusting the, having to adjust this intensity level on it. So it makes me think that there is something just a little bit buggy. Can't quite put my finger on it. It might just be that I'm not particularly familiar with this scope, and I haven't used you know, this kind of analog layout in, you know, 5 years. and it's amazing how quickly you forget how not how things work, but you know, I mess with that many different types of equipment. You forget how things work. The other scope that I've got that I used to use more frequently, I've got an old HP scope, and that just seems a much more intuitive interface to use. Although I'm a massive fan of tektronix scopes, I've got the new Keysight 3024T, the new touchscreen scope, and to be honest, I detest it. I think the user interface on it's total garbage. I got it because it had a nice big screen on it, and my eyes aren't as good as they used to be. But of course, what they do is they put a really big screen on. They make it, but it's such high resolution that they make the text even smaller than it was before, so I can't read that either. But yeah, maybe I should go for one of these PC type scopes with a big monitor on it. Maybe that'll suit my eyes better. Yeah, this scope seems to be working remarkably well now. It's been on about an hour, and it doesn't seem to be exhibiting the failure. But I know that when I try and use it in anger, it will fail. So yeah, don't know. Having just been spent the last 20 minutes using it though, I don't look back with quite the fondness that I did. It's actually quite a little bit of a pain in the arse to use. I mean, one thing, it's nice having most of the controls on the front panel, and again, that's one of the annoying things about about my more modern tektronix scope and the Keysight scope, that to do anything you've got to access about 6 different menus. Oh, that's what it feels like. So it's actually really quite nice having, you know, everything available on the front panel. You forget how nice that is. And yeah, the main reason I actually bought this scope is that it's actually got a 50 ohm setting as well, which is lovely. The other thing about the interface on this scope is all the buttons are actually quite close together, so that makes it a little bit of a fiddle, but I suppose it is quite a compact unit. That's what I was always going to say. It just seems to be really quite frustrating at times that it feels like you're constantly having to mess with the intensity controls and the focus. But, you know, I forget, is that what scopes were like? Perhaps they were. My old HP 100 MHz scope, that thing's a joy to use. The reason I don't have it on the bench anymore is because it's just too deep and it takes up too much room. It doesn't have any digital display or cursor, so it is a proper analog scope, the old HP that I've got. But that's a joy to use. I love that scope, but I just don't have room for it on the bench. And that's the main reason that I stopped using this, because I just don't have the room for it anymore. Oh look, beam find. Don't you love that? God, it's been years since I've had a beam find button. Let's just see what other measurements we can do, because as I say, it's been that long since I've used this scope, I can't even remember what it does really. So, measure frequency, measuring progress, 3.5 kilohertz. Yeah, that looks a bit about right. But I just noticed when I took that measurement, it's actually dimmed the display, so I'm going to have to fiddle with that again to bring it back up. So is that a bit of a problem? Let's do that again. Measure 1. So it does the measurement, but when it comes back, it's actually dimmed the background trace. Is that normal? Should it do that? Is that a fault? I don't know. Well, I've definitely got to go back and... I don't know. Just constantly playing with it. Right, okay, let's try some other measurements. Measure volts, so that must be 2. And what have we got there? We've got 38 volts peak to peak. Where does that go? Is that about right? Let's have a look. 5, 10, 15, 20, 25, 30, 35, yeah, near enough. Yeah, so it's funny, you set the trace to the brightness you want, but whenever you do a measure, let's just go back and measure the frequency. Measure 1. When it comes back, it's dimmed the trace. Do they all do that? Now I've got to go back and readjust that. That's just really annoying. Well, it looks like our oscilloscope there has failed to show its fault. It's been on a couple of hours now and it's working annoyingly well. So it can go back in its cupboard for another 2 years, at which point I'll get it out again. I guess we've got nothing to do now than put this thing back together. But annoyingly I can only find 3 of the screws. That'll do. Bye for now.